All right, I'm here today with Todd Anderson. Hi, Todd. We're going to be taking a look today at our revised 0 to 10 volt dimmer, which you can see here on the table, and some of the switches and controls that can be used when installing this product.
Correct. So what we're going to do is going to go through each of the different wire schematics and the different controls that you can use for that, and then we're going to dive into each one and how they operate.
Sounds great.
So first off, we're going to just look at basic functionality. We have the option, so we've created a wire schematic for the very simplest of solutions, which is a residential or commercial toggle switch. Very simple, full open, full close, operation only. There's nothing in between. And so we have that option for you. Next, we have a control with no load to control. There are many different types of this type of controller. In particular, this one we're showing the Lutron DVTV, which we do offer for purchase here at Solatube.
Got it.
In addition, through many of the changes that we've done with the PCB board and the 0 to 10 volt daylight dimmer, we've been able to include a controller with a load to control. Now previously in the previous 0 to 10 volt daylight dimmer, we had some difficulties with operating controls or using controls with a load to control. So we've made some fixes and we're able to use those controls now. What we're looking at now is this one here is with a load to control. This is another Lutron product. This is the DVS TV, and this does have a load to control. It's a very simple wall box control only, so there's no control board that has to hide up in the plenum space or in a control room. But you can go as elaborate as this Eaton here, which is does the same functionality. This is a full room controller, so you can go as sophisticated as this here, which has scene controls and clearly a lot more components inside here for controlling the entire room. So these items can be purchased outside. They're sourced outside, usually during specification phase. Right now what we're going to do is we're going to look into the functionality of the unit with the load to control, and so we're going to dive into that right now.
All right, and Todd, just to make sure, when I buy my 0 to 10 volt controller I'm going to install, the product obviously is right here on the table, and then these instructions are coming with it. So I'm going to pull out the instructions, I'm going to see all 3 wire diagrams, and then I'm basically determining, depending on the type of controller I want to use, which wire diagram I want to use. And then we're going to dive into each of those individually, correct?
Correct. So they've been included, the wire schematics have been included at the very end of the installation instructions for convenience of use. So you don't have to pull off the website. They'll come in each of the kits that you receive, so making it that much easier for the installation.
All right, great. Looking forward to diving in. All right, Todd, we're going to get started here with the simple stuff. This is our residential or commercial toggle switch. So we want to make sure that we've got the right wiring diagram ready. And I see you've got everything pretty much set up for us to go. So tell us what we're going to be doing.
All right, so this is the simplest of solutions for the 0 to 10 volt daylight dimmer. This is for just functionality of full open or full closed operation for the daylight dimmer. And this is for just the easiest solutions that people don't want to source controls. They want to keep on a budget. So this would be the only operation. There will not be any intermittent in between. You can't go in any of the steps in between. So it's either full open or full close. So make sure everybody understands that. Now, this is a residential toggle switch that we picked up at the hardware store across the street. This one in particular is a Leviton Decora style switch. And we went with this one here because during the design of this, we found that no matter how we hook this up, in the upright position, in the on position, that the dimmers are actually closed. So rather than a regular toggle switch like we see here, because on the toggle switch it shows the off position and the on position, we're suggesting that we don't use this type here. So this would be probably something we wouldn't want to use just because of the indication of the on or off position. The reason for that is because we have to turn this upside down to get it to operate correctly to match the rest of the operation of the switches in the gang boxes. And so with this style, this Decora style toggle switch, we can actually take this and then invert it and then set it inside the gang box, put the plate on, and then it'll operate correctly. So now this is in the off position. And we've looked at the actual, for wiring, we've looked at the wire schematic here. It shows here for residential or commercial toggle switch. And we're showing the red and black connections that are coming into the control line, into terminals 7 and 8. And then we're also looking here at the transformer that is located directly over here. And then in this section here, we're looking at the actual PCB board of the 0 to 10 volt daylight dimmer. So control or power coming in, 24 volts coming in, and then terminals 1 and 2, and then going back out to subsequent dimmers up to the maximum amount for this for the style that you're using, whether Skyvault or for Solamaster.
Got it. All right, so Todd, just walk me through those physical pieces that match the diagram there. We've got the toggle switch, obviously.
Toggle switch would be indicated here.
Yeah, you mentioned the transformer.
The transformer is located here, which is this unit here. And currently we're using a 96 VA transformer for this one. This is what we have hooked up.
And that's available here at Solatube as well.
That is available at Solatube. This would be sourced outside. Toggle switch would be sourced elsewhere.
Got it.
The schematic here for the PCB board for the 0 to 10 volt daylight dimmer is located here as indicated on the diagram itself.
Excellent.
So once this is wired correctly according to the wire schematic, so we just have red and black coming in through control line through here, through terminals 7 and 8 right here. And we have power coming in from the transformer into terminals 1 and 2. Now, this one, in the instructions here, or the wire schematic, it says for this type of control, we want to make sure that we remove the jumper from the first unit only. So it shows there what you're seeing on the screen. And what we're going to do is then take out, we've already conveniently removed it, but we're going to take out that jumper there, and it has been removed already.
That's that 2-pin there, and it has the plastic jumper sleeve removed.
Correct.
And you can just show me real quick there, Todd, the other jumper on the board that's still intact.
Correct. This is jumper number 1, and this is jumper number 2.
So that's got the plastic sleeve on it still, and the board comes with both sleeves installed, correct?
Correct. So they would come with both of them installed. So if you wanted to see what it would look like, you just take that jumper and then remove it. So perfect. If it comes from the factory, installation-wise, I'm going to get my fingers in the way here real quick. It would be here. So that jumper would be installed. According to the wire schematic, it says to remove it on the first unit, so we'll just remove it from the first unit. And for video purposes, let's just put that back into number 2.
Perfect. So remove number 1 and leave number 2 in place.
Correct.
Got it.
So once we power this up, this should be able to operate correctly now. So this is in the off position. Down would be typical for your hallway or bathroom or anything like that, or in a classroom or anything like that. You'd see a switch that would be down, indicating that it would be off, so we'll have full close. If we push full open, the unit opens full.
Got it.
So only 2 operations with this, full open or full close. And this one's pretty simple.
Fantastic. All right, thank you, Todd.
You bet.
All right, Todd, now let's dive into the next level. Not too complicated, but a little bit more complicated with the DV-TV switch. This is the product that we carry here at Solatube as our recommended relatively easy switch to install. And this is going to be the wire diagram of 0 to 10 volt, no load on-off switch. So we want to make sure we have that diagram pulled out. And let us know what you've done here, Todd.
So what I've done is I've already hooked up all the wiring according to the wire schematic here. This diagram, this wire schematic is for any controller that has no load to control. We're showing the DVTV because we do offer it, but there are many others that are just like this here that would be hooked up just about the same according to their specifications, but would be very similar to connections here. So we're utilizing the DVTV. This is a Lutron product, and again, we do offer it here at Solatube. I've made all the wire connections based on the wire schematic here. So I've taken the and you can kind of see here, the red and white wire and the violet wire, and connected to the 0 to 10 volt control. So you can see here we've got that red and white with violet and our red control that's going to go out to the daylight dimmer. Down below we have the gray line and the blue line hooked up to the black, as you can see here. The red wire itself is capped off. It's not needed in the specifications or the controls for the DVTV. It shows also to cap that off because it is not needed for this operation. And so looking at the components here on the wire schematic, we have indication of the controller, which is this piece here. We also have the transformer, Class 2 transformer that we offer here at Solatube. This one again, this is what we have currently hooked up, which is the 96 VA. Again, that is offered here at Solatube. That's providing power to the daylight dimmer. And then we also have this piece here, which is the actual daylight dimmer, the 0 to 10 volt daylight dimmer, indicating the PCB board connections here. On the wire connection, we've hooked up everything according to the wire schematic here. So if we turn power on, everything should work correctly. One thing to note here is in this section of the schematic, we're showing current sinking or current sourcing controls. Now, in particular, this Lutron controller is a current sinking unit, but some units may have a current sourcing solution. If it's a current sourcing, we just need to follow this piece here. This one's telling us for current sinking, we're going to remove the first jumper from the first unit. So we're going to remove jumper number 1. If it is current sourcing, we're going to keep that jumper in place in order for it to work properly. So you can see here, what we need to do at this time is remove jumper number 1 right here for it to work properly. So we're just going to take it, and let me get my fingers in there, and we'll just pull it right out, and then it'll just set aside, as we won't need that for any of the operation. So if we hook power to this, turn the power on, we should get full operation here. This, as opposed to the simple solution for a toggle switch, this is going to give us 0 to 10 volt control. So we're going to be able to open it to any position that we're desiring for the scene, for the room, whether it be an office space or a classroom. In this case, it's in the off position, so we're going to turn it back on. It is down. The slide is going to give you the 0 to 10 volt functionality. So we're going to turn it on. And this is the number 1 position here. And so we're just going to be able to then slide and then move it up to whatever position that's desired. So it does have memory. So if we do turn it off, it will actually close full. And if we turn it back on and leave it in that slide in the full position there, it will actually go back up to the full open position. And again, so the slide on here will give us the 0 to 10 volts. So if we want to just dim it halfway, we can slide it down in the halfway position, and then we have reduced light coming through all the way up from just about 10% to full off, then to full open at 100% or 10%.
Got it. All right, very cool, Todd. Thank you very much.
You're welcome.
All right, Todd, now we're going to get a little bit more complicated on this one. I noticed you got a few more wires in front of you. And on this, we're going to really dive in, and we're going to do the controller with the load. So we want to make sure we pull up the right wire diagram here. And I'm going to let you tell us what's going on here.
Great. So, James, as you mentioned, this is a wire schematic for a controller that has a load to control. Now, previously on the previous daylight dimmer, we weren't able to utilize controls that had a load to control. We had some issues with the connectivity between the two, and it kind of limited us to having controls with no load. With the changes that we've made to the board, we're able to utilize those controls now. So we have one here in play. This is a simple wall box control only. There's no controls up in the plenum space that would be necessary. This is another Lutron product. It is the DVS TV, and it does have a load to control. But this is a simple wall box solution. You can go as elaborate as on any of these controls to full room controls. We have some options here that we've listed in the technical bulletin that we have for it as well, and so we have a long list of those as well. We wanted for ease of video shoot here, we wanted to use something a little simpler that we can show here. Essentially the same connections though. So as we dive into this and look at it, so we do have the Lutron product here. It is the DVS TV that has a load to control. We wired this up according to the wire schematic here. And so if we take a quick look at this, all the components that are listed on here, we have the switch indicated here, which is this guy right here. We also have the power that's providing power for the 0 to 10 volt daylight dimmer, which is our 96 VA transformer, which is able to be purchased here at Solatube. A note for the DVS TV, this is something that is sourced elsewhere, so this is something we do not provide. Looking here, we also have our 0 to 10 volt PCB board, so we have it showing here, indicated. And I don't know if you noticed or not, but there is a second transformer here on this schematic, which is necessary if you're going to utilize a control that has a load to control. It will be necessary to provide a second transformer. We're suggesting that you use a 20 VA, which we have here, and this is available through for order through Solatube that you can purchase from us. So if we look at the wiring for this here, and we'll explain why we need a secondary transformer when we get to that portion of it. But looking at the wire, we have hot power coming in, so from any circuit coming to the switch itself. So it's going to show power coming in. So this is your power line coming into the switch itself. And now if you look, this shows switched hot, also 0 to 10 controls. We're going to go over the 0 to 10 controls shortly. But we're going to look at the line here. So this is switched hot, which would be the red wire here, which is going to provide power to the secondary transformer. The secondary transformer is basically going to mimic a ballast for a typical lighting system, fluorescent applications, or LED fixtures that you would see in a commercial setting. Basically what we're providing is a dummy load for the switch itself to send a signal to. Without this operation here, this would not work. But we have to be able to send a signal somewhere for this in order to work. And so what we've done is we've provided a transformer for it to send the signal to, and it provides power to the transformer itself. Now when we look back here at the 0 to 10 controls, we're going to go back here. So we have 0 to 10. So we have our purple to our red and gray to our black in this particular one, and it's going to go provide power, provide signal that's going to be installed here into terminals 7 and 8. So you can see here you've got terminals 7 here and 8 here, which are your control lines. Now, looking back, we have the 96 VA, which is going to provide power, so it's going to provide 24 volts to the actual board itself, which is going to go into terminals 1 and 2 here. And this is where power is coming in to provide power to the daylight dimmer. Now, we have on the dummy load, or the other transformer, we have actual control lines that are going to come out. So these are your low voltage signals that are going to send a signal from the switch itself to the transformer, and then it's going to come back out, and we're going to hook it up just as it shows here to the control line, or sorry, the dummy load line, which is going to be installed into as you can see here, is going to go into terminals 5 and 6 here. What that does is it allows that transformer then to send a signal to our board. Our board will recognize it as the dummy load and say, we're not going to do anything with it. We recognize that it's there. We can go ahead and function now. Whatever that switch tells us to do, it will open or close as to what location you're looking at. The last thing we want to make sure that we do here is that when we look at the schematic, we want to see here what it tells us to do with the jumpers. Now we have jumper number 1 and we have jumper number 2. In this particular case, we want to see if it's a current syncing or sourcing control. Now I've conveniently taken the instructions from Lutron in their box there, and I've looked here, and I can tell on all the instructions for just about any of these controls that as I see here on the lines here, this is maximum capacity, it says load, and it also says 0 to 10 volt sync. So this is a syncing controller. So when we look at that, now we can understand what to do here with our jumpers. And this is syncing, so we want to follow this direction here. It says remove the first jumper from the first unit. So we're just going to remove it from the first unit only. There's another line here that's going to tell you, so if it's a sourcing one, you're going to keep that jumper in place. But on this jumper number 2, this is the only time jumper number 2 is going to come into play here. And it says remove jumper number 2 from the first unit when using the 0 to 10 volt controls with a load to control. So in this particular case, because it's a syncing unit, we want to remove jumper number 1 and jumper number 2 from the first unit only. So let's go over here. So we're going to take jumper number 1 here, and we're just going to take and get that out of there, pull it off. It pulls right off. We'll just set it aside. And now we've got jumper number 2 here that we don't need on this particular unit either, so we're just going to take it out. And so the jumpers are then removed. So now, if we provide power to this, and if I've hooked everything up correctly, it should function properly. We'll go ahead and provide power. Now, this is a slide switch that's very similar to the DVTV. It is a Lutron product, so it's going to look very similar to it. So what we should do is, it's in the closed position now. Let's go ahead and push it to the open position, or on, or give it power. Now the slide's all the way at the bottom, so it is fully closed, and now we can have slide functionality here. So my wiring is correct, and we should be able to get full range operation for it. And then we can go full back, full close. And then full open again. And then we can turn power off. And if we turn power back on, it does have the memory, so it'll go back to the last position wherever that slide switch is at.
All right.
So the biggest difference on this one here is it has the dummy load, or the secondary transformer that's necessary for operation for a control unit that has a load to control.
Fantastic. Well, Todd, thank you very much for making a complicated subject slightly less complicated.
You're welcome.